Good morning, everybody. Yeah, thank you all very much for attending this morning. I'm going to start a bit slowly to allow one or two other attendees to join us. But for those who have, thank you ever so much for attending our What's New in eCADSTAR 2021. We'll make a start. We're hoping to only keep you for about 30 minutes today. Due to time constraints, what we'll do is at the end, if possible, if you do want to ask questions, by means jot them down. We won't have the opportunity, I don't think, today to do a live sort of Q&A at the end, but we'll happily come back to you individually with responses to any questions you may have. So a brief introduction. Today I have with me one of our eCADSTAR applications engineers, Sarah Sant-Angeli. I don't know if I got that right, Sarah?
Yeah, you got it right. Well done.
Excellent. I'm getting there a bit more. But that's the thing I've been rehearsing for the last day, just your surname. But we've also got, I'm getting better all the time. And we've got our marketing coordinator, Vicky Last, who very kindly has helped to arrange this event today. And obviously, hi Vicky. And obviously last, and by all means least, it'll be myself, Michael Ray, Sales and Account Manager for UK, Benelux and Scandinavia. Most of you attending today, I'm sure I've spoken to at some stage. Sarah was going to kick us off today, but before she does, I've just got to run through some of the points we're going to try and cover. We've got the Creepage Checker, Spice Controller, the RINF import, the EDIF import, and then just some general additional features and enhancements. Hopefully you'll benefit from learning what's in the new latest edition, and I'll hand over to you, Sarah, for the Creepage Checker.
Okay. So the Creepage Checker within eCADSTAR's PCB editor is a powerful tool, and it's so much more than a basic clearance check. The voltage difference can also be changed based on the requirements for a voltage difference range. The flexibility and sophistication is down to the user control. So in this design, I've maximised input voltage to 600 volts at the power connector of our demo PCB. The first thing we need to do is define the voltage. Just going to pause that 1 second. So you're just seeing I've defined the voltage in the constraints browser. This is used in combination with the design rules to create appropriate spacing to avoid creepage issues. So in this demonstration, we'll be focusing on the 600 volt signal. Okay. So the next thing we need to do is go into the rule editor. There is now a new voltage difference tab. Here is where we define the creepage rules. So I've defined here 3 clearance tables: external coated, external uncoated, and internal. These rules are based on IPC standards, which provides a formula for adequate clearances regarding creepage. So you can use the formula or enter a defined value. This is therefore a clearance which varies with voltage difference, but can also vary within a range of thresholds, making this a sophisticated solution for creepage rules. The voltage rules can also be defined as RMS or peak values. So you can see there, we've got some thresholds there. I've used the formula in the rules and then assign them to the conductor layers. So from the report tab, we can now invoke the Creepage Checker. You can set a search distance. So here I've used 5 millimeters around what is selected for the creepage check. Then eCADSTAR will check in X, Y, and Z, and even around the edges of the PCB. Once you've selected a signal, net or the entire board, a results dialog will appear where you can filter by caution and fail results. So we're just focusing on this 600 volt error here. So you can see from the results that the creepage issues exist. So creepage distance on the same external layers for the 600 volt signal. So all we need to do is double click cross probe and you'll see this error line. So this error line is very helpful as it's guidance where we need to rectify the creepage failure. So we can have a little look in 3D mode as well. And then you will see that error line there on layers 1 and layers 8 as well. So I love the interactive trackball, so you'll probably see me messing around with it quite a lot. There are a couple of other errors on this design on the pin next to it, but we're just going to focus on pin 3 there. Okay, so we're going to take the traditional approach of inserting a slot in between the signals using eCADSTAR's slot command. And then we're going to invoke the Creepage Check again to see if we still have failures or if they have been resolved. Okay, so you can do a select window, or you can select a particular net, or you can select the entire board. So let's say, okay, so that's done. We've still got failures there that we need to resolve, some violations. But you can see that the error path there, the creepage path, has now changed. So you can see that change there on layers 8 and layers 1. Always nice to have a little look in 3D mode, see how that board's going to be built. Okay, so in this case, we probably need to make that slot a little bit longer. Again, just demonstrating the cross-probing capabilities there, and that's on layer 1. Okay, so to make this slot longer, we invoke the Properties tab, and we can just click on that slot in 2D mode, and then we can just increase the length there. Okay, now we can invoke another Creepage Check to see. Okay, so we have significantly less errors there on that 600 volt line. So those errors have been resolved. So if we just go into the pass section, we can now have a look at the creepage path there. So you can see it also, eCADSTAR also shows you the creepage path from conductor, the top conductor to the bottom conductor there. So generally, when you put a slot in, you've created a new path there. So you can see now that those violations have been resolved. And that's the Creepage Checker.
Thanks for that, Sarah. Thank you. So just a general overview then, just to highlight some of those features and benefits. It's obviously a powerful advanced creepage design and check. You know, we can design right, and with advanced creepage design rules, we're reducing the iterations and design rework. But it's a powerful rule specified to voltage difference beyond traditional clearance. Clearance varies with voltage difference as opposed to discrete values. Creepage design consideration integrated within design rules. It's efficient and productive design environment, a much more improved design review efficiency, and Creepage Check to reduce overall design time and improve the quality of work. And finally, design and verify to IEC 62368-1 from the outset and during the design process. So moving on from there, Sarah, you can introduce us to the LTspice simulation tool. That's okay.
Absolutely. So let me introduce you to the next feature of eCADSTAR, eCADSTAR's Spice controller. Start the video. So here we have a simple inverted amplifier circuit that we're going to use just to demonstrate the Spice controller. So first thing we need to do is set up. So we go into the application settings, we set the executable path and the pattern library of the simulation models. In the properties, you can link components to their corresponding Spice model and define additional parameters. So this is the inverted amplifier, and these are the voltage sources. Okay. So from analysis, Spice controller, we can invoke the Spice controller manager. From here, we can set up a transient analysis by setting up parameters. So we're just going to select the condition transient. And then you can enter your parameters there by double clicking on that transient there. So net output simulation, we've now invoked the SPICE program to simulate. So we can see that V out has been amplified by 1 volt there. Hopefully you can see that on your nice big monitors. Okay, so just a demonstration of the DC sweep analysis. So again, we select the settings, so you can add settings in here. So these are ones I've done earlier. Okay, just for demonstration purposes. And then double click and then you can enter your parameters in there and your target. So net simulation output, there we go. Now we've our lines disappeared, so we're just going to set that to visible. And it's chosen a very faded purple colour, so hopefully you can see that well. Okay, next AC sweep analysis. Again, double click on the parameters, set your analysis settings, AC sweep, double click, set the parameters. Okay, net simulation output. Let's have a look at V out. There we go. So you can see the slew rate of the amplifier there. Okay, operating point display. It shows the voltage property on each net in the design. See that there. There's a little arrow there as well, so you can delete those as and when. Parameter sweep. So here I'm showing a parameter sweep on R1. You can override parameters and pin orders to match the model in the Properties tab. Here I've defined a variable for R1 and inputted a formula to calculate R2. Then we execute a parameter sweep. Again, make sure you've got your settings there. Double click, input our values and our parameter name. So we're going to increment R1 by 1K each time. So you can see there the effects of R1 changing in value. We can also have a little look at the steps as well if you want to interrogate a little bit further. So we go to 6K and then we can see the effects on V out there. Okay, simulation frame, so we don't have to simulate the entire sheet. We can deploy simulation frames. When we frame netlist out, eCADSTAR gives us an option to define simulation characteristics of nets across that frame. So you'll notice here I'm just going to leave the global and power symbols out of the frame, and then we can watch what eCADSTAR does here. Frame netlist out, we'll save, and then there you can define your characteristics for your simulation. Okay, so automatic voltage generator. This time I'm going to create a frame and I'm going to cover the entire amplifier there. This time when we do a frame netlist out, we're going to select automatic voltage generation or generator. Execute. So it's eCADSTAR has automatically generated voltages from the power symbols there. Okay, so that was a little quick insight into the SPICE controller. There are a couple of other points to note as well. So the SPICE controller can support Monte Carlo analysis with LTspice. This can be configured in a schematic by specifying SPICE parameters as required. Temperature analysis is also supported. This can be achieved in 2 ways, either by entering the SPICE directive as an include file or as a model parameter. Additionally, frames on the same sheet can be simulated as one by naming the frames the same name. So very, very powerful tool there. The key features and benefits.
Yeah, thanks for that, Sarah. So just an overview there of what Sarah's already sort of touched on, with a single circuit diagram for simulation, design and verification, and PCB design, significantly reducing re-entry time and design errors. Integration with commonly used de facto standard analog simulation tool, which, as we say, is pretty much a preferred tool used for simulation. Reduced retraining for simulation environment, all integrated into eCADSTAR, of course. Much more powerful and efficient circuit design solution. As most of you are aware, we've touched on it already, LTspice is the most requested and utilized SPICE-based simulation solution. Netlist from eCADSTAR may be suitable for use with other SPICE FreeFX-based simulators, for example, Simitrex. And the SPICE controller provides an enriched integration for simulation defining information within the circuit design. The dataset includes circuit and functional verification, delivering traceability and collaboration communication of the circuit design. So, thanks again for that, Sarah. And I think you've got just sort of a general overview now of some of the other features that have been added.
Yes, so there's quite a few other features and enhancements that have been added. So just the final sort of video I'm going to talk you through. So there's quite a few little perks and things as well. So I'll try to include as much as possible. So firstly, we have a RINF import. So if we, in the PCB editor, we can now import a RINF netlist when we open a new design. Okay, so you can see it's brought that information in quite easily there. Just turn off the display to show you the lovely components distributed on a nice grid. Next, we have EDIF import. So one of the migration tools. So we can now import EDIF files. Okay. So give it a name, DC-DC regulators, and a location for it to go. So migration is successful, so you can see how easily it's brought in that EDIF information. So eCADSTAR has done a great job there, bringing in all those symbols and all that information there. We have a symbol select menu, so your power, ground, your sheet symbols, references, and your global symbols can now be accessed from the ribbon. So it allows easy access there for when you're in your schematic. External tool commands, we can now invoke external programs. So in this example, I'm just going to use CAM 350 because I'm in and out of there quite a lot. Obviously, you can use Excel, you can invoke Excel, anything you like, your Gerber viewer, that sort of thing. I'm just going to go one step further here and place a button on the ribbon and create a new tab as well, just to show you how easy this is. So external tools. I might add to this, there's a couple more programs I'm in and out of as well. So I mainly use this program to view Gerbers. So, okay. And I'm going to make that icon big. Little tutorial on how to customize your ribbon as well here. Okay. So external tools, and now click this button here. and then it's invoking my external program. Okay, so we now have DXF import in the symbol and schematic editor. So again, obviously we have that in the PCB editor and the footprint editor still, but we now have this available in the schematic and symbol editor. So just a little demonstration there using our logo. Okay, design fields and sheet page numbers, etc. So we now have quite a few more options in our sheet settings, our properties. You can see there. You can apply to all sheets as well. So you can display viewer in the schematic editor, or you can do what I'm about to show you now, which you can go into the symbol editor, go into symbol settings, and display the viewers. So it already comes in like that when you pop the sheet border in the schematic. Okay, so I'm just displaying viewer on some of these properties, and then I'm going to place them on the border as quick as I can so you don't fall asleep. I did speed this up quite a lot because I'm quite slow. So we've got a design title there, current page number, total page numbers, created by date. Again, I'm just using a couple of them just to demonstrate. So if I now do a reload on this border, reload on the symbol, and then we should have all our design fields come through. There. You see that? That's picked that up. So sheet 1 of 8 here. Let's go to sheet 2. So you can see that's all nicely intelligent, picking up those different titles as well. Okay. Again, you can display them in the schematic editor as well. So I'm just bringing in a company name there. So. Okay, so we can now cross-reference our sheet connectors. So we can display the location on the sheet connectors. So you can just do this easily in the properties. And you can display where that sheet connector is linked to. You can see there, linked to page 3 and 8. "3D measure." So we have a 3D measuring tool. You can measure from surfaces, edges, and vertices. See there. Curve trunking. So we can execute curves around the trunk. And then we can click and drag and it will alter the radius as well. Okay, so they're all dynamically connected in there. Okay, just a couple of other enhancements. Okay, so we have some network performance improvements. The speed has increased. CADSTAR to eCADSTAR migration scaling. Access to the PCB rules in the schematic editor. Simplified bus labels. Enhanced scripting, so we can read and write to the library. Variant component rename, so you can rename the reference designators in the PCB editor. Import and export IPC parameter files. Analysis results viewer improvements. It's more high speed PI/EMI analysis module improvements. And we now have free schematic and PCB viewers that you can download from the eCADSTAR website and also from the Quadra website. So you can send to your customers.
Excellent. Thank you very much for that, Sarah. Well,
No
we've actually not been sort of bombarded. We only have a couple of quick questions that have been sent at this stage, but just to highlight, I will be following up with everyone who's attended today. So if there's any other further questions following on, you want to get through to myself or Sarah, feel free to do so. A quick one, actually, I'll just answer now from Paul about the features included as standard. But I think the majority of today's features are included as standard. For example, the Creepage tool is actually from the Advanced 3D bundle and an Ultimate. So obviously you need the 3D tool to be able to do those creepage checks. So as long as you've got the Advanced 3D, then that will work from there. Sarah, I don't know, have you seen the second question from Michael, or have we got time? Or
I'm just going to whiz through this video and just answer the question about here. Okay, so you can see here, you can, you've got your clearance tables here, so external coated, internal, and then I've assigned those to a conductor layer, those rules to a conductor layer here. You can see, so this is an 8-layer design. So I hope that answers that question.
So yeah, on that note, we'd like to thank you all very much for attending. We'd like to say, please do continue to pass feedback and enhancements requests to Quadra and Zuken. The development team there are sort of continuously working, very, very hard to develop this software, make the improvements that are necessary along the way. And we're very, very open to hearing what customers who are essentially driving the software, you the customers who are driving it, ways that we can look at improving it. So please do continue to pass on feedback and enhancements requests. And yeah, like I say, we're really grateful for everyone attending today. That will be followed up in the next week or so. Any other questions between now and then, please don't hesitate in contacting us. And Sarah, Vicky, thank you very much for your time today.
Thank you, everyone.
No worries. Thank you very much.
Bye-bye.